Hi, folks. Thanks for joining our presentation about the fact-enhanced synthetic news generation. I am Yichuan Li from Worcester Polytechnic Institute, and I want to thank my co-authors, Dr. Kai Shu from Illinois Institute of Technology, Kaiser Ding, and Dr. Huan Liu from Arizona State University. Before this paper was finished, many self-attention-based language models like Grover, BERT, GPT-2, and Transformer have achieved great success in text summarization, language translation, and synthetic news generation tasks. However, these methods can be abused to generate fake news and fake reviews. If so, how can we work together to protect the whole society from this attack? So from series modeling, to prevent the potential attack, we should firstly identify it and prioritize it. In other words, we should build up a stronger attack model to understand the characteristic of the generated content. And then we develop a defender to defend these attacks. So in our situations, to defend the synthetic news, we should firstly build up a better synthetic news generators. And then we need to defend this new attack. And for social good, we will not release the checkpoint of these models. So let's first look at the characteristics of the real-world news pieces. So the real-world news pieces contains two important features. The first one is fact consistency, which is the news bodies often surround the claim, which is, for example, mentioning the name entities listed in the title and keeping the relationship among these entities. And the second feature is a fact richness, which is the body of the news pieces often provide the supplementary information of the claim. Let's look like the example shown in the right-hand side. So the news claim mentions the judgment of Iran nuke agreement, and the black box test in the news body, which is related to the fact consistency, mentions the agreement-related information. And in the meantime, the red italic test, which is related to fact richness, provide many supplementary information like the location and the time of this agreement. And it should be noticed that the term fact we used here is related to the information as evidence or as a part of the news articles. So this definition is according to Oxford Dictionary. However, to our best knowledge, existing generation method cannot meet this goal at the same time. So for the fact consistency, the language model generates specific high correlation tokens instead of overall consistency, which means the generated content is not support the input news claims. And for the fact richness, the consistent generation models, just like copy mechanisms, often misses the essential details to supplement the claims. And directly fine-tune the existing language models on the target dataset doesn't help in the generation performance. And we will show this in our further experiment. So in this task, we aim to generate fact-consistent, fact richness, and fluent news content at the same time. So we utilize the text reconstruction strategy to improve the text consistency. It will utilize a masked language model to reconstruct the input news claims. And for the fact richness, the generated content is much longer than the input claims. So we should provide more information at the input side. So we consider explicitly improve the richness at the input side. So this will not only help us improve the factual richness as output, but also allow us to control the supplementary information because we can provide the auxiliary information for the generation. And last but not least, to generate fluent and readable text, we utilize the pre-trained language model as our basic model. So here, we utilize GPT-2 as our decoders for the synthetic news generation. So this will provide a lower bound for the test fluence and test readability. So let's look at our problem setup. So we firstly have the input claims. Let's take the judgment of Iran nuke agreement, for example, and we utilize these news claims to retrieve related fact information. So this retrieve rules is heuristic rules to retrieve the uh, related informations. And finally, the model generates the news content based on the news claims and external facts. Let us check the overview structure of the proposed method. The main model contains three main parts, and each part have different functionality. To improve the fact richness, we utilize the fact retriever to heuristically retrieve the supplemental information as input. And to improve the fact consistency, we utilize a randomly initialized masked language model to reconstruct the masked news claims tokens. And since we need to generate fluent, readable, fact consistent, and fact richness news content at the same times, we utilize one language model to balance this all requirement. And we have two objective functions. One is masked language loss, especially for the test consistency, and the causal language loss, which is for the test fluence and readability. And our final objective function is a weight combination of these two objectives. So the causal language loss is to predict the next tokens of the news body based on the input news claims, external facts, and the already generated content. And the masked language loss is to fill the masked blanks of the news claims based on the unmasked claims and the hidden representation of the generative text from the decoder part. Although the fine-tuned GPT-2 have been applied to many text generation tasks, synthetic news generation is not suitable for it. So this is because GPT-2 doesn't have a specific encoder. It cannot capture the dependent relationship between the news claims and the retrieved facts. The poor performance at the encoder part will impede the final generation performance. So to get help from the GPT-2 and omit the drawback of it, we consider GPT-2 as a decoder and utilize a randomly initialized task-specific encoder to capture the relationship and to encode the bidirectional informations. So to combine the random initialized encoder and the pre-trained decoder, we utilize pseudo language model, which is to expand the self-attention space of the decoder. So from this figure, the random initialized encoder is in yellow, while the pre-trained language model is in blue. The encoder will transform include the input news claims and factual information into the key value pairs and inject these pairs into the decoder's self-attention modules. Like mentioned before, if we directly train a sequence-to-sequence model on the news claims and news contents, we will face the fact scarcity problems during generation. So we manually increase the fact information on the input side. We retrieve the fact information into two steps from coarse to fine-grained. So we firstly retrieve the related documents based on the TF, IDF, cosine similarity. Then we utilize a BERT to encode the sentences in the document and retrieve the top K sentences based on the embedding cosine similarities. And finally, we concatenate all the sentences into one document and consider this as an external fact for given news claim. Because of aforementioned modules like fact retriever, pseudo language models, bring the inconsistency during the test generation. So we need an extra mechanisms to guarantee the consistency between the input news claims and the generate news content. So we consider the input claim reconstruction as a regulator to constrain the input. So given a news uh, input, we mask several tokens and we utilize the hidden representation of the decoder's output to reconstruct these masked tokens. After introducing the whole approach, let's move on to the experiment. In the experiment, we want to answer two evaluation questions. The first one is related to the tech. We want to know whether the generated test is in high quality and can fool the human. And the second question is about the defense. Can we detect these synthetic news pieces? So we utilize two real-world news datasets in our experiments, which are Gossip Corp and the CNN Daily Mail datasets. So for Gossip Corp, we consider the title as a news claim, and as for the CNN Daily Mail, we utilize text summarization as a news claims. And our target is to generate the long news bodies. As for the external fact corpus, we utilize the news content in the training dataset as external information. So this will omit the information leakage problems during the evaluation and can provide reliable performance evaluation results. We firstly report the automatic evaluation result among 5 baseline methods. They contain the model without pre-trained language model, the pre-trained language model, and the fine-tuned language model. So we evaluate the test quality in consistency, richness, and fluency. So for consistency, we utilize a stance detection model to detect whether the generic content support the news claims. And for the richness, we report the number of unique name entities in the generic test. Last, for the fluence, we report the blue 4 scores. So from the evaluation results shown in the figure, we can find out that our method achieved the best performance in all the 3 evaluation metrics in CNN Daily Mail. However, for the richness metrics at Scholar Corp, our model achieved the second best performance. So this is because the size of external fact corpus of Gossip Corp is smaller than the CNN Daily Mail's, and the fact retriever cannot find enough factual information for the generation. Overall, our model is best among all the baseline methods in 3 different metrics. Let's move on to the human evaluation result. We asked the human annotators to review the generic content from the test fluence, richness, consistency, and trustworthiness. So the human annotators need to answer these 4 questions and report a score from 1 to 3, where the higher score is better. So from this figure, we can find out that our approach achieved overall better performance compared with other baseline methods. In addition, we also present the generated samples. And from these samples, we can find out that our generated one provides auxiliary information, like the experience of one businessman and the discussion about the nuclear weapons for the Iraq nuke agreement. And at the same time, our generated test focus on the opponents and the agreements in the nuke framework. However, baseline methods like Grover mentioned the unrelated information like IMDb, GPT-2, and PPLM didn't mention the nuke agreement and contents in this agreement. So let's move on to the second evaluation questions. Can we defend the fact-enhanced synthetic news? Here we consider two groups of defending methods. Fake news detection method and machine journey test detection method. For both groups of methods, we assume they can only access a limited amount of generated data and enough amount of in-domain dataset. So for the fake news detection method, they can access the human-written fake news and human-written real news and a limited amount of machine-generated fake news. And for the machine-generated detection method, they can access the machine-generated test and the human-written test, and also a limited amount of machine-generated fake news. So for the machine-generated fake news, we utilize the fake news claims to generate the news content. So this can somehow guarantee the generated content is not real. And in the meantime, we also propose a fake news detection method, which based on the previous checkpoints of our method. We fine-tune the classification head of the checkpoint on limited amount of generated content. So from the experiment results, we can find out that the fake news detection method and the machine-generated text detection method cannot fully identify this generated text. And our method can achieve the higher accuracy score. So to conclude, in this paper, we consider the fact-enhanced synthetic fake news attack in the future. To simulate this attack and identify the characteristics of the generated context, we provide a fact-enhanced generation method. The model utilizes text reconstruction to improve the input claims and output content consistency. And to improve the factual richness, the model retrieves external factual information to improve the richness during generation. From our experiment results in human and automatic evaluations, our approach achieved the better performance compared with the baseline method. And we recommend you to join this competition. If you are a defender, try to defend the fact-enhanced synthetic news. If you are journalists, you can use this tool as an auxiliary writing tools.